I built the mixer. You can see it's a surface mount that they put on a little, whatchamacallit, so it's easy to solder. And you got the big rig, so somewhere around 7023 we'd expect to hear the tone if we turn it on. The oscillator's going, and oh, there it is. About there, so 7024.3. This is on receive, frequency the oscillator is running on, and transmit it somewhere else. So if we look around, oh, there it is. 7023.5. So what's that, 800 hertz down? So that's a reasonable offset for getting a good side tone. Now I put the dummy load on the KX3, tuned it to the frequency. Oh, maybe turn the backlight on. You can see it. Tuned it to the frequency that the receiver was at, and this is just a little wire to help pick up the signal. And you can key the KX3, and we should be able to hear it coming out of our receiver here. So if we turn it on, start recording. Oh, I gotta tune off a little. So yeah, that works. So now we've got power, receive, audio amplifier, side tone, the mixer. So now we've got this the driver and the power amplifier. So I think I'll just build it as one big stage. There's nothing very interesting. We just see. I think I'll build it in 2 stages. I'll build the driver here. I have to decide if we put the 9018 or the 8050 in, it looks like. Or maybe there's 2 in parallel. I don't know. And then test that, and then we'll put in the power amplifier transistor and the low pass filter and test that. And it looks like there's a little TR bicolor LED here. So I built the buffer or driver, whatever you want to call it. It's the stuff around this transistor. And then I hooked up the scope probes already, so the yellow is on this C4 coming from the mixer to the input. The purple is on the output, the C13 here. So we can look at the scope and see what they're doing. Plug it in on key up. You can see the yellow, which is the oscillator built into any 602, is doing its thing there. And then when I key down, we'll see the purple trace. And I should note the yellow trace is 500 millivolts per division. The purple is 5, so it's 10 times bigger. And there you go. 5 volts RMS. It's about half a watt. And the driver is working. And you can see it's not the purple one there is not a very good sine wave, which means there's a whole bunch of harmonics and stuff. But that'll get cleaned up in the low pass filter on the output. So we built the driver, build this power amplifier and output filter, and test that. Might do this LED at the same time, and once we've done that, I'll have to decide if I want to put this on, but we should have a working transceiver at that point. Well, I figured out how to wind the toroids. Got the whole transmitter on, so now I've got it hooked up to my watt meter, SWR meter, and we'll be able to key down and see how it looks. So if we can, we will turn that on, 0 watts, key down, 0.9, not bad. Here we can see we got power. It's about 7 volts RMS, so yeah, that's very slightly under 1 watt. It looks like a pretty good sine wave, so hopefully the filter is doing its job, but we can check that by doing a little DSP. Put the rest of the components on. There's that LED. I decided just to bypass the RF gain. There's just a little jumper on the back there. And I also played around with, which one is this? L4, which provides power to the power amplifier. The instructions said it needs 11 turns to get 22 microhenries, but if you do the calculations, 22 microhenries is only 8 turns, so I took off a couple turns. Got slightly more power, so I'll do it, but we can see we plug it in. There's a green LED. When I key down, it turns red. The scope, it up to about 7.1 volts RMS, which is just about 1 watt exactly. So now we just gotta take it out and try it out.